Buenas tardes, bienvenido a otra edición del Renewable Tuesday en Glen International. Durante el día de hoy tendremos Ironridge hablando de los sistemas de Ballasts. Tendremos nuestro presentador a John Haim, que nos estará explicando todo el sistema de Ironridge. Y todas las preguntas o dudas que tengan, por favor, vamos a hacerlas a través de nuestro sistema del chat de preguntas en el servidor. Y vamos a darle comienzo ahora a nuestro presentador, a John Haim, que nos va a estar hablando sobre los sistemas de Ballast.
Okay, thank you. So today we're going to talk about the Ironridge BX ballasted system. My name is John Hamey. I'm the Senior Technical Support Representative for Ironridge. I have over 27 years experience in the solar industry. I've worked 17 years as a contractor installer, and I was certified NABCEP installer when it first came out in 2003. I'm still involved with NABCEP as a volunteer. And I've worked 7.5 years with 2 different PV module manufacturers, and I've been with Ironridge for 3 years now. Carlos, are you with us, sir? I've also have Carlos Maldonado here. And he's
I'm here.
Okay. Yeah, you want to give you a brief introduction?
Yes, so my name is Carlos Maldonado, and I'm the technical support and trainer for Ironridge. And actually, I've been with in the solar industry more than 10 years now, working on the racking and mounting side of things. I was actually with Quick Mount PV for more than 10 years, and now I've been with Ironridge for about a year and been working basically doing the same thing, training and handling the technical support. I also speak Spanish, so I'll be happy to answer any questions you guys have in Spanish, or if you need any training in Spanish, I'd be happy to support as much as I can.
Cool. Thanks, Carlos.
Yeah.
So today, I'll give you a brief introduction to Ironridge, and then we'll talk about the BX system and components, a little bit about site conditions and design, go through the installation, and I'll show you how to use Design Assistant, our design tool. And we'll also should have time for questions and answers. So Ironridge was founded by Craig Carney in 1996. He worked in the construction industry, and he saw a need for mounting systems for solar at the time. I worked as an installer back then, and we were making our own mounting systems out of angle aluminum and anything we could figure out. And he really was a pioneer in the industry to help bring pre-engineered systems, mounting systems for solar. Ironridge is part of the ESDEC group. ESDEC is the largest European module or mounting system manufacturer, and they also have EcoFasten and PanelClaw under the umbrella, but Ironridge and Quick Mount operate as one business unit under the ESDEC umbrella. Ironridge makes a flush mount system for pitched roofs, a tilt mount system for flat roofs that's attached, and a BX ballasted system, which is what we'll talk about today, and a ground mount system. Quick Mount makes roof attachments for both pitched roofs and flat roofs. And so any type of roof, from comp shingles to tile to cedar shakes, metal shingles, slate, post standoffs for flat roofs. So any kind of roof we have attachments for. So we have our independent certification through ETL, Intertech, and also we're ISO 9001 company, and we have our own internal testing programs, and we are an ETL recognized test lab. So all of the as companies under the ESDEC umbrella can do testing through our test labs. So the BX ballasted system and components. So it's available in a 5 or a 10-degree tilt angle. It's a fixed tilt. It's really fast to install with minimal parts, and it's a lot of power density on the roof. And also it's designed only for use on flat roofs. That's anything from 0 to 7-degree slope. And there are mounting options for string inverters and also anchoring solutions where additional anchoring is required. So the chassis is our BX chassis is the heart of the system, and it's available as a 5-degree or 10-degree. It's the same chassis. It's just the placement of the hardware that changes the tilt angle. And so you order the tilt angle that you want, that hardware will be in the place for that tilt angle. So the row spacing for a 5-degree is 10 inches. And for the 10-degree, it's 13 inches. And so this increases our power density because our competitors are up to like 19 inches for their row spacing. So we can get a lot more power on a roof with this closer row spacing. So the chassis is made from BASF Ultra Mid, which is a hybrid component or polymer, glass-filled polymer. And it's actually used in the automotive industry in the rear axle cross beams of Mercedes and BMW vehicles. So it's really a high performing material. So it's corrosion resistant, electrically insulated, fire resistant, and UV stable. So it's a roof-friendly, footprint. The ribs are stiffened, and it raises the ballast rock blocks up off the roof. So this spreads the load across the chassis. And also, because it's raised up on there in those ribs, there's airflow underneath, so you're not trapping moisture underneath the ballast blocks, and it gives good drainage underneath. It's also fully fenced. So this is really important in an area where there's earthquakes. So in a seismic zone, typically a ballasted system, the ballast needs to be either glued or strapped in place to hold it in if there was an earthquake. Because we have this basket shape, no additional restraining is required. So these chassis also stack, so it makes storage easier and shipping, and also easier handling on the job site. So, and as I mentioned, there's a pre-installed hardware, so you don't have to fiddle around with as many bits or pieces, and it's installed in either the 5-degree position or the 10-degree. So the clamps, there's a top and a bottom clamp, so it grips both on the top and the bottom of the module. That bottom clamp, you pull it tight up against the flange underneath. And so this makes the retention a lot stronger to the chassis. So we also have an optional anchor solution, which uses our flat roof attachment and L brackets that connect to the chassis. And then you would buy strut locally to connect these together. And this helps reduce the amount of ballast required, and also helps in a seismic zone or for earthquakes or in high wind regions. So the wire management is all done either on the chassis or on the module frame, so it can have a nice clean look. And so from module to module within a row, it just follows along the chassis and on the module frame. And from row to row, it follows the chassis, and we have the edge clips that clip onto the chassis to help for wire ties for managing the wires. So if you're using microinverters, you can attach that directly to the chassis using the MLPE hardware, or if you're using optimizers. And if you need bonding and grounding, another option is to use, I'll show you in another slide, there's a accessory bracket that attaches to the module frame. If you're doing string inverters, we have a kit for that, And you would need to verify with this inverter manufacturer that they're okay with mounting at an angle like this. But it's a way to mount the inverters out in the array at the same level. So we'll talk a little bit about site conditions and design. So, you know, we all wish that all flat roofs look like this, where a large area with no obstructions and, you know, nothing to worry about. But in reality, most roofs have different shapes. So whether it's, you know, T-shaped or L-shaped or U-shaped, or it might be multiple towers, or, you know, different levels. This can affect the design greatly in terms of how wind reacts on the building shape. The other thing you have to consider is rooftop obstructions. So, you know, air conditioning units or heating units on the roof, drainage or electrical runs on the roof, skylights. We have to work around all of those. So the BX system is flexible, and we can work around obstacles. So it's a good idea to understand the roof construction, particularly if you're using an attached, the hybrid attached system, is to understand whether you're using a metal framing and decking or wood framing and decking, or like in Puerto Rico, most of it is a concrete deck. This will have an effect on the design. So also to consider whether this is for a residential project or a commercial project. The BX is really designed mostly for a larger roof, so it works best on a commercial project. It can work on a residential project if the building size allows for it. And residential code is more prescriptive with safe engineering margins. A commercial code allows for a more analytical approach to minimize building materials. So it's a different engineering approach depending on which type of structure you're working on. So design loads, primarily in Puerto Rico, we're talking about wind loads. I know you don't have snow there, but for those of us that live where there's snow, that is also a design concern. So the International Building Code and ASCE 7 are the design, you know, is where we need to consult for our design considerations. I know Puerto Rico is using ASCE 716, which is under the International Building Code 2018. And so there are different wind maps for 710 or 716. And so you need to make sure that you're going by the right wind category. And our design tool has choices for ASCE 710 or 716. So something to understand about flat roofs is that the edge and corner areas are subject to higher suction effects from the vortices as the wind is flowing over the building. So we take that into consideration with the different roof zones as we're designing a project. We've done extensive wind tunnel testing, or we've consulted with wind tunnel testing that's been done on flat roofs, and this is the basis for our design in the design tool. So the shape of the roof needs to be defined for that. Also, the building height is very important. So the higher building, the more the wind speed. So you can adjust the multiplier, use this multiplier here based on your wind or on the height of the building to multiply the wind speed. So in an earthquake prone area, also taller buildings are subject to more movement. So it's important in the design to understand the height of the building for seismic zones and how that affects the design. So roof zones are defined as, you know, zone 1 is the middle of the roof, that white area there. And zone 2 are the edges of the roof, the yellow area. And then zone 3 is the corners, the red area. And these dimensions will vary depending on the height of the roof. But it's important to understand what those roof zones are. And then with our ballasted system, there are additional setbacks to consider as well. So we'll talk a little bit about the installation. So really, it's pretty simple and it doesn't require a lot of tools. So we recommend a cordless drill with a clutch and, a socket and adapter, some hand tools, a screwdriver and pliers, channel locks to put on the ground bonding straps, and a torque wrench that measures in inch-pounds, and of course, measuring tape and marking tools and a string line. So the components that are required in this system are, the BX chassis, the top clamp and the bottom clamp hardware for attaching the module, a ground lug, and the bonding jumpers that go from module to module and from row to row. And then the ballast blocks, which you would buy locally. We do not provide the ballast blocks, but we give you the specifications, how many blocks you need. So the other accessories, if you're using microinverters, the MLPE mounting assembly goes to the chassis of BX chassis, but the chassis is not grounding. So if you want that optimizer or inverter, microinverter grounded, we recommend you use the quick mount accessory frame bracket, and that attaches to the module frame. And also you can use, we have edge clip cable ties, the inverter mounting assembly kit, and then if you're doing the attachments, you would want the flat roof mounting assembly and the membrane flashing depending on the type of roof. If you just have a concrete roof, you don't need the membrane flashing. So we recommend to go on our website and review the installation manual. It has all the before you install, so it provides the instructions and module compatibility information in there. And this is our official UL 2703 and ETL listing document. So getting started, you want to make sure that you determine the array dimensions and review all the fire setbacks provided, and look at the project plan set and engineer drawings, and make sure you understand the complete layout on the building before you get started. And you can, in our installation manual, it depends on the module, the size of the module will determine the layout. So we have a chart in there that shows the different module widths and how that affects the chassis spacing. And it also depends on the tilt angle. So this is a quick and easy way of determining how you're going to lay out. But what an easier way, and most people understand, is to actually just assemble 4 modules in a block on the roof to get started. And then you can take your dimensions from that, because everything is going to follow this and lay out the same all throughout the whole system. So this is a good way to start, is just start small with one small section, and then create an L shape essentially, and go with your front row and one side of the row. So you're going to mark, your first array corner, and then measure along the array edges and mark all 4 corners, and place a string line and chalk out your east-west lines and north-south line. You don't need to mark the individual chassis locations. You can minimize the time spent on the array layout by only marking the array corners. So there is a center mark for easy layout in the chassis, and this would help you align things as you go. So measure your chassis spacing along an east-west line, and measure this chassis spacing along the north-south edge. And then you can just place the rest of the chassis loosely. They don't have to be placed exactly, because once you start those first 4 modules, really everything is going to fall into place. There are pre-marked spacers on the chassis themselves, so that everything kind of just falls into place. So also, if you have a membrane roof, we do not require slip sheets. The chassis has rounded corners. It's a polymer material, so it's not going to poke holes in the roof. But if you have a membrane roof and the membrane manufacturer requires it, this would be the dimensions for, you would use the chassis dimensions for your slip sheet dimensions, and slip sheets are typically just the same material that the roof membrane is. So the ballast blocks, there's 2 sizes, a full block or a half block. So they're both, 8 by 16, 8 wide by 16 long. The full block is 4 inches thick and the half block is 2 inches thick. These should meet ASTM C1491 for roof pavers. And if you live in an area that freezes, they should be freeze thaw resistant to ASTM C1262, and should have a compressive strength of 3,000 psi. And then the typical weight of a half block is 14 to 17 pounds, and a full block is 28 to 34 pounds. So when you go to place your blocks in the chassis, we provide a ballast plan that tells how many blocks in each chassis, and it's going to vary. The ones on the edges are going to have more than the ones in the middle. So it's a good idea to have somebody with that plan go around and mark the required ballast on each chassis with a crayon, construction crayon, and then place the ballast blocks in the bottom of the chassis. And then it's best to place the ballast prior to the module installation, so that you're not having to stumble around the modules placing the blocks. And if you're doing anchor attachment, then you would not have you would not need ballast in those anchor chassis that are to be anchored. So for installing the modules, you place the bottom clamp on the chassis, place the module over the bottom clamp, and pull that bottom clamp so that it's secure up against the flange underneath. Put the top cap on and tighten to 120 inch-pounds. So there are module alignment tabs on the chassis. So all you have to do is butt the modules up against these tabs, one in the center and then one to the edges for the proper placement by the clamp. This makes sure that everything is aligned quick and easily without having to measure things. So it's best to begin by installing one full module row east to west, and then install one column of modules north to south, and then build out from that. So, that way you created your straight lines and your spacing, and then you're just filling in from there. And there's no further measurements because you're using the module alignment tabs. So then you want to do your electrical connections and secure the wire against the module frame, and make sure that there are no loose or hanging wires. And your north-south wire management is by attaching to the BX chassis. So grounding, we use a bonding jumper because, again, the chassis are not made out of metal, so they do not provide a bonding path. So these jumpers just snap onto the module frame. And then we also have row-to-row jumpers as well. So you only need one ground lug per continuous array, and that would mount to a module frame. And it's best to use a pair of channel locks to squeeze these on. I think there's a picture of that. Yeah. So The 8-inch jumpers are used for the east-west grounding, and you engage that to the module frame, and then use a little electrical tape wrapped around the jaws of your channel locks so that it doesn't scratch the module frame. And then you just squeeze that on there. It's really quick and easy. So then the 38-inch jumpers are used for the north-south grounding, and you secure one to a module frame, then secure it to the chassis between the rows, and then all you need is one ground lug per array. So for optimizers or microinverters, and actually this should have actually been put on before the modules are put on. I should make a note of that. So you want to install the cage nut and thread to the 5/16 flange bolt into it, and then attach the microinverter device and tighten it to 60 inch-pounds. You can also attach to the module frame if you need bonding and grounding through the module frames. And that would be with you make sure you follow the instructions of the manufacturer of the microinverter or optimizers for proper bonding and grounding. So if you're using a string inverter, you can use our kit for mounting that to one of the chassis, and essentially using some rail and some L brackets to put that together, and the inverter can be mounted on there. We have full instructions in the BX installation manual. So if you need to do attachments to the roof, you would secure the L feet to the chassis, and then attach the strut to the channel, and then you would put your anchors in and attach that to the strut. So the anchors can go in after the modules are installed, because the placement of that is pretty important, and you can't move that once you've put holes in the roof. So you want to make sure that the array is properly placed before you put these anchors in. And if you're using a membrane flashing, then you can have a roofer come in and seal that, or you can seal that with just using a sealant on a concrete roof as well. So it's a really simple system. This is what it looks like installed, and it goes together quite fast. And you can do a large roof area in a short order of time. So I want to talk about Design Assistant. And before I go into Design Assistant, this auto calculates your loads and provides a project report and stamp letters for permitting, and generates a complete bill of materials. You'll get a ballast map with the amount of ballast required in each chassis, and we can provide you with, if it's a rectangular shaped building, we can provide you with all the documents you need for permitting and a ballast map. If it's a complex shape or multi-level building, we have a commercial services team that can provide that information, but it will take additional engineering. So if you have a large commercial project, we can turn that over to our commercial services team, and they can provide you everything you need to get started. So let me go back and get into Design Assistant here. And so if you go to our website, ironridge.com, you would go to the flat roofs. And then if you want to find out more information, you need documentation. In the drop-down menu, select flat roof documents. And then in that documents, you can find the is the tilt mount system and the ballasted system. There's a tab for each. And here you will find all the information for slip sheets and ballast block guide, the installation manual, CAD blocks, certification letters, and cut sheets are all here. So these are important for the documents. Now for our design tool, you would go to design tools and select ballasted flat roofs. I already have a tab open. And if you have an account with us, you would have a list of my projects, and in your projects you'll have all of your projects that you've had for every system, and you can go back and edit or do anything you need. So I already started a project here. So we're going to jump in here and look at this. So here is where the code selection is. So initially, when you first go to the window, I'm already in the project here, but you would put the address of the location in the first window, and then it'll take you to this page. And then here you can put your project name and select the code. If in Puerto Rico, it's going to be 716. The wind and snow load will be automatically put in. If you know that the wind speed is a little different than what is here, you can edit that depending on what your local building department requires. Your wind exposure. If you don't understand what something is, click on this little information bubble here, and it'll pull up information to tell you what that means. So in this case, exposure B for wind exposure is urban, suburban areas or wooded areas with other obstructions. Exposure C is more open terrain with scattered obstructions, and exposure D is a flat, unobstructed area like on the coast. And then the risk category, risk category 2 is for most residential structures, and 3 would be more commercial structures. And then you select your module manufacturer and the model number here. And then if you have, and I should point out that if the module is not here that you're going to use, you can contact us at support@ironridge.com, and we can add new modules to the system. And also, if you're using an older obsolete panel that's not in here, you can create a custom panel as well with the dimensions of the panel. So now you're going to need to put in here your building information. So you need to know what the building height is, the dimensions, north, south, and east, west. And also you need to know whether there's any slope to the roof, and parapet height, and the parapet thickness, and any fire setbacks. So if you don't have a parapet, just put 0. We need to have some value here, and same with the thickness. And the fire setbacks would be based on your local code there. If you know the roofing material, you can put that in. That's if you have a membrane type roof like TPO or PVC. And the roof manufacturers will be here based on what you select and the color and the thickness. If it's just a concrete roof, just select no. You don't need that information anyway. And here, this is where you're going to choose the tilt angle, whether it's a 5 or 10 degree. And then also whether you want half blocks or full blocks. A lot of times people use half blocks. They're easier to move around. And also in some cases, you don't need a full block. So half blocks are going to be more efficient use of the ballast. And because Puerto Rico is a seismic area, typically in this selection, you're going to have some kind of anchors required. So if you're not in a seismic area, you could do the prescriptive method with no anchors or none required. but in most of Puerto Rico, I believe you're going to have prescriptive with some anchors involved. The spectral acceleration just has to do with the soil properties in the seismic zone and then the seismic design category. And these values are automatically put in based on the address you set in there. And the setback is required by Ironridge for wind zones. You cannot put a system right up against the edge of the roof. And then if you have optimizers or microinverters, you can add those in here. And if you need string inverters, you can add that here as well. And also the accessory frame bracket or the mounting hardware is available there. So this section here, I believe, is not visible in the public version of this. This is just a tech support there. So now you would go to the roof editor, and this dimension is predetermined by what you put in the roof dimensions up here. So whatever you put here plus the setbacks is what you'll get here. And this yellow zone is your setbacks. So this whole gray area and white box is what you have available to put in for your array. So once you click on something, you can go back, you can click sections, and if you want rows in between, or if you want to make one solid block, that's what you would do. So, and if you need to go back and remove for obstacles on the roof, say you have HVAC or something, you can go back and remove modules as well. And then once you have that saved, your system will be set up. So you could also do this as a complete block. So, so if we want to fill all of those in, you can do that as well. So once you have the system the way you want it there, you're going to come down here and it's going to show you this ballast map. Now, because we're in a seismic area and the wind load is so high, you're in a hurricane zone and a seismic zone and a high wind area. So the ballast requirements in here exceed what a chassis can hold, and that's where these red baskets are. It would require 200 pounds of weight to hold that one chassis in such a high wind and seismic area. So that's more than the chassis can hold. So in this situation, what you're going to need is to have contact Ironridge, and we can assist with placement of anchors to help reduce that load. And actually, I will point out too that in a lot of cases, especially smaller residential systems, our tilt mount system will probably be better for you to use in a hurricane zone with seismic concerns. There'll be less weight on the building. It'll be fully attached and designed to the system. And you can go back and watch that tilt mount presentation if you haven't seen it already. But this ballasted option can still be an option, and you would need to work with us to see where we need to place anchors. And then up here is the bill of materials. Once you have the system, and you'll have a list of everything you need. And if you need to add wire management, you can add those here, click save, and that will be added to the system down here as well. So you would take this bill of materials and you can email that to your distributor, Glen International, and send them a bill of materials of either PDF or in a spreadsheet form, and or you can print it and hand it to them in person. Also, we have certification letter for Puerto Rico, and the flat roof attachment certification letter, the installation manuals, CAD drawings, and cut sheets for all the components here. Also up here, you can get your layout. This is where you will find your ballast map, and then there's an engineering report. So this is a good thing to have on the site for your workers. And let me show you what that looks like. So it'll tell you how many blocks need to be put in. And like I say, in these red blocks, it's more than the chassis can hold. So you're going to need to do additional in this particular instance. So I don't know if the whole island of Puerto Rico has the same seismic zone or if it's just parts of it. That you would have to check with the local building department for that information. But that would affect the system design. Also in our design tool here, if you want to share this project with other people, if they have a design assistant account, you can email to that person. And also it's a good idea if you have questions for us, for technical support, you contact us and go to My Projects. And in My Projects, this project ID number will be there. If you share that number with us, we can look up your project and walk through any particular questions you have about that project. So I think I've gone through all of the important stuff here a little faster today. So if we have any questions, you can submit them in the chat and we can help. If you're in Spanish, Carlos can help with any of those questions. Carlos, do you have anything to add to what I've presented?
No, you did a fantastic job, John.
Thanks. So it's a really simple system, and you know, we think that, let me go back here. So you know, like I said, you can, if you have a large project, please contact us. We will help with commercial services. They have all the ability to do the anchor placement. And also coming in the future, we will have the ability for the design tool to do more complex layouts. Currently, it can only do rectangular shaped roofs and give you a ballast map. You can still create a layout in it, but the ballast map will only be valid for rectangular roofs. In the future, that design tool will be available for more complex roofs. And commercial services can certainly help with any of the more complex roofs. And these ballast maps will really help you there too. So I want to go back to the picture of the system. So if you have any other questions, please submit them in the chat. And if you think of something later, and you can always email us at support@ironridge.com or give us a call, and we are happy to answer any of your questions.
Hi, John. Thank you for your presentation, and thank you, Carlos, too. Interesting system, the Ballast system. If any people have any questions, can write in the chat, or it's okay. I think this is the final of the presentation. Si alguna persona tiene alguna duda, nos puede comunicar en Glen International, la División de Energía Renovable, 787-757-6000. Con cualquiera de los compañeros de energía renovable, estamos a la orden aquí en Glen International. Muchísimas gracias.